Ever wondered how numbers are organized in different ways? Hello, math learners. Hassan here. Welcome to our journey through Algebra One. Today, we are diving into a fundamental topic that lays the groundwork for many mathematical concepts: the set of numbers. Whether you are solving equations, graphing functions, or manipulating expressions, a solid understanding of the set of numbers is the key to mastering algebra. In this topic set of numbers, we'll talk about various number sets which are characterized by the nature of its elements and the rules that govern them. So, what is the simplest idea of a number? It's something to count with, right? So, we start off with counting numbers. Now, these counting numbers are also called natural numbers. The numbers we use for counting are the natural numbers. So 1, 2, 3, 4, 5, and so on. We can describe these counting numbers inside the braces. So we have 1, 2, 3, ellipses. So this ellipsis indicates that the numbers continue to infinity. Last but not the least, the symbol for natural numbers is n. Next, we have whole numbers. If we include 0 with natural numbers, we get the set of whole numbers. So the set of whole numbers is the set of natural numbers plus 0. So again, we can use braces to indicate this set of whole numbers. We have 0, 1, 2, 3, ellipses to indicate that this is also continuing to infinity. The symbol for whole numbers is W. The next set of numbers that we have is called the integers. The set of integers adds the opposite of the natural numbers to the set of whole numbers. Within the braces, we can see that we have the opposites of the natural numbers. Then we have 0, and then we have the natural numbers. So it is useful to note that the set of integers is made up of 3 distinct subsets: negative integers, 0, and then positive integers. So you combine these 3 subsets to write the set of integers. The symbol for integers is z. Now next we have rational numbers. Any number that can be written as a fraction is called a rational number. We can express this rational number in a formula of p over q, where p and q are integers and q is not 0. So this p is the numerator of this fraction and q is the denominator of this fraction. So the denominator cannot be 0. The symbol for rational numbers is q in block letter. Now let's look at this example right here. Here we have p equal to 3 and q equal to 2. Now this fraction p over q becomes 3 over 2. Now this 3 over 2 is also equivalent to 1.5. So 1.5 is a rational number. Now here is an important note. Every natural number, whole number, and integer is a rational number with a denominator of 1. So let's say if I have 5, I can write this 5 as 5 over 1. If I have 0, this 0 is a whole number. I can write this 0 as 0 over 1. If I have negative 10, I can write this negative 10 as negative 10 over 1. You can see that we can express the natural number, whole number, and integer as a rational number with a denominator of 1. Since rational numbers are written as fractions, they can be expressed in decimal forms. Doing that, we can have terminating decimal and repeating decimal. Terminating decimal is a decimal number that contains a finite number of digits after the decimal point. We can see that after this decimal point, we have 3 digits. So it ends right here. Now for the repeating decimal, this is a decimal in which after a certain point, a particular digit or sequence of digits repeats itself indefinitely. Over here, we can see that for the terminating decimal, 15 over 8 is written as 1.875, so it does not continue after 5. Now for the repeating decimal, we have 4 over 11, which can be written as 0.36, 36, 36, 36, and so on. We can see that this 36 is repeating indefinitely. So we can put a horizontal bar over the repeating digits. So we can write 0.36 with a horizontal bar on top of 3 and 6. Up next, we have irrational numbers. Irrational numbers are numbers which cannot be expressed as a fraction of two integers. The symbol for irrational numbers is I. For example, the square root of 2. We cannot write this square root of 2 as a fraction of two integers. There are many more rational numbers. Pi is a famous one. Now, the sets of rational and irrational numbers together make up the set of real numbers. The symbol for real numbers is R. In fact, a real number can be thought of as any point anywhere on the number line. So if you take any point on this number line, that point is within the real number system. That number could be a rational number, it could be an irrational number, but it's within the umbrella of real number. Now we can form a Venn diagram to show these number sets together. So we start off with the natural numbers, which is symbolized by the letter N. And then we add 0 with this natural number to include the whole number set. And then we add the opposites of these natural numbers to include the integers. Now, if you want to include the decimal numbers and those numbers which are not expressed as natural numbers or whole numbers or integers, we include the set of rational numbers. Which is symbolized by the letter Q. Now, the set of irrational number is I. And now if we add these rational numbers and irrational numbers, we get the set of real numbers. So this is represented by R. You can see that all these sets are within the system of real number. So this is explained over here with some examples. We can see that within the natural numbers, we have 1 and 10. In the whole number, we have the 0. Then within the integers, we are including the negative numbers. Then in the rational numbers, we are including the decimal numbers and terminating decimal other fractions. And then we have the irrational numbers over here. We have pi, square root of 5, negative square root of 7. And all these are coming under the umbrella of real numbers. Okay, so let's see this practice problem over here. The problem says, name the set or sets to which each number belongs. So the first problem that we have over here is 0 over negative 2. If you simplify this number, 0 over negative 2 simplifies to just 0. So that means this 0 is in the set of whole number. So we use W here. And then this whole number is also a part of integers. So we have Z over here for the integers. Then this integers is a part of a rational number. So we have Q over here. And this rational number is a part of real numbers. So we have R over here to represent the real numbers. Now let's look at the second problem. We have 19 over 8. Now this 19 over 8, we cannot reduce this to any natural number. We cannot have this as a whole number, and it cannot be an integer either. So we start off with the rational number. So this 19 over 8 is a rational number, so we represent this by Q. And then since rational number is a part of real numbers, so we represent this with R as well. Perfect. Now let's see some more examples over here. For number 3, we have negative 5. Now negative 5 is not a counting number. It's not a whole number because whole number starts from 0. So this negative 5 is an integer. So we start off with the integer which is represented by Z. And then this integer is a part of rational numbers, so we have q and then r. So remember that once you start with the smaller circle, then you just go to the next circle, which is outside of that smaller circle. So we can say that all natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers, and all rational numbers are part of the real numbers. But the reverse is not true. We cannot say all real numbers are rational numbers. We cannot say all rational numbers are integers. And we cannot say all integers are whole numbers. And we cannot say all whole numbers are natural numbers. So remember these three. So if you start off with a smaller circle, then you can go to the next circle, which is outside of that smaller circle. Now let's start with this 0. So this 0 is a whole number. So we start off with w here, and then we have integers, so that's z, and then we have rational numbers, which is q, and then finally we have real numbers, which is represented by r. For number 5, we have 19/4. Again, 19/4, we cannot simplify these to any natural numbers. 19/4 cannot be simplified to any whole numbers either, and it cannot be any integers. So we start off with the rational numbers. So that is q, and since rational number is a part of the real numbers, so we have r. Awesome. For number 6, we have 14/15. Again, this is not a natural number. It's not a whole number. It's not an integer. So we start off with the rational numbers, which is q, and then finally we have r. Okay, let's try these 4 problems quickly. -28/-2. We can simplify this to 14. Now this 14 is a counting number. So we start off with the natural numbers, which is n. So you can write that this 14 is a part of n. Since natural numbers are part of whole numbers, so we have w, and then we have z, and then we have q, and finally we have r. Awesome. Now let's look at this -12. -12 is an integer, so you can write this with z, since integer is a part of rational numbers. So you can write q and finally r to represent the real numbers. Okay, number 9, we have -9. -9 is not a part of natural numbers. It's not a whole number either. So you start off with the integers. So we have z, and then z is a part of q, which is the rational numbers, and then we have real numbers. And finally, we have square root of 0. We can write this in simplified form. So the square root of 0 is just 0. So you start off with the whole numbers. So you start off with the whole numbers, and then we have integers. Then we have rational numbers, and finally we have the real numbers. So what would we do if we have a case like square root of 7? Let's take a look at this example. So this square root of 7, we can write this as the part of irrational numbers. So we start off with I, and this irrational numbers is a part of real numbers. So then we have r to represent the real numbers. So if any number is an irrational number, then this irrational number set also belongs to the real numbers. So there you have it, the set of numbers explained. Quick recap, we started by exploring the basics of sets, delved into various types of numbers, and even navigated the real number line. We also saw a Venn diagram showing the subset relationship between the sets of numbers. That's it for this video, and I will see you in the next one. Now let's get to study.